Here is a question that comes up the first time you think about running 3D Secure as its own step. In the usual setup, the payment processor runs 3DS for you, which ties that authentication to that one processor. If the authorization fails and you retry somewhere else, the customer has to authenticate all over again. So the real question is this: can you authenticate once and still send the authorization to any PSP you want? The answer is yes. That is the whole point of standalone 3DS in Hyperswitch. The authentication runs as its own step, separate from authorization. An external 3DS server, Netcetera, Cardinal, 3dsecure.io, or the Juspay 3DS server, runs the AReq and ARES exchange with the card network and the issuer's ACS, and produces three artifacts: a CAVV, an ECI, and a DS transaction ID. Hyperswitch carries those into the authorization request and routes it to whichever PSP you choose: Stripe, Adyen, Worldpay, Checkout.com. The PSP just sees an authenticated authorization. It does not know or care which 3DS server produced the cryptogram. So you authenticate once and you keep your freedom to route. So why go to this trouble? Standalone 3DS decouples those two steps. The merchant controls authentication independently. You choose the 3DS server, you set the exemption logic, and you decide which PSP gets the authorization after the cryptogram is generated. That buys you three things PSP managed, 3DS does not give you. First, fine-grained control over each authentication request and the checkout experience. Second, visibility into how issuers actually respond: exemption outcomes, challenge rates, and ACS behavior, broken down by bin. You see the authentication layer instead of having it hidden inside a processor. Third, and this is the one developers care about most, a portable cryptogram. A CAVV generated by an external 3DS server is a standard EMV 3DS version 2 artifact. The result of the authentication is in the ECI value. Any PSP will accept both the CAVV and ECI value. In Smart Retry flows, that matters directly. The same authentication cryptogram can be submitted across multiple PSP authorization attempts. You do not re-authenticate the customer between tries. It helps to be precise about who owns what. The 3DS server owns the exchange with the directory server, the ACS challenge coordination, and the CAVV itself. Hyperswitch owns the exemption type decision through the 3DS intelligence engine, the order of the pre-authenticate and post-authenticate calls, the routing decision, and the construction of the authorization payload. Three things cross the boundary in the direction that matters for liability: the CAVV, the ECI, and the trans status. The CAVV is the proof of authentication. The combination of ECI and trans status decides the liability shift. Let me walk the whole thing once, top to bottom, so you can see where every piece sits. 7 players. The customer's browser on the left, then Juspay Hyperswitch, then the 3DS intelligence engine, the external 3DS server, the directory server, the issuer's ACS, and on the far right, the PSP that will authorize the charge. It starts with one call. The browser sends payments create to Hyperswitch with request external 3DS authentication set to true. That flag is what puts us on the standalone path. Before any 3DS traffic goes out, Hyperswitch asks the 3DS intelligence engine for an exemption decision. The engine evaluates the transaction across its configured parameters and hands back an exemption type. This is the part you do not get with PSP Managed 3DS. The exemption call is yours, made before authentication, not buried inside a processor. Hyperswitch then calls pre-authenticate on the external 3DS server, the Netcetera or Cardinal or 3dsecure.io you configured, and passes the card data along with that exemption type. The 3DS server builds the AReq, the authentication request, with the exemption indicator embedded and sends it to the directory server. The directory server forwards the AReq to the issuer's ACS. The ACS is the issuer's authentication server, and it is the one that decides what happens next. Here the flow splits two ways, depending on what the issuer decides. Let's go over the first branch, the easy one. Here, trans status comes back as Y, frictionless. The ACS is satisfied without challenging the customer. The ARES, the authentication response, returns frictionless approval to the 3DS server, which reports authentication success back to Hyperswitch. The customer never saw a thing. Now, the second branch. Trans status comes back as C, challenge. The ACS wants to verify the customer directly. The ARES says challenge required. The 3DS server returns a challenge URL to Hyperswitch. Hyperswitch tells the browser to render the OTP challenge, and the customer completes authentication straight with the issuer's ACS. This is the branch your front end has to be ready for, because the issuer can pick it even when you sent a clean exemption. Both branches rejoin here. Hyperswitch calls post authenticate on the 3DS server and pulls back the three artifacts that matter: the CAVV, the ECI, and the DS transaction ID. The CAVV is the proof that the authentication happened. In this whole flow, you never saw the PSP. Now it enters the picture. Hyperswitch sends the authorization to the PSP with that authentication data attached, and the PSP returns the authorization response. Look at how late the PSP shows up. Everything to its left is already finished. That is why the cryptogram is portable. The authentication is complete and signed before any processor is chosen. So you can point this last arrow at Stripe, at Adyen, at Worldpay, and the rest of the picture does not change. So how do you run this yourself? It comes down to 4 steps. First, set up a 3DS authenticator in the dashboard. Then, create a payment with external 3DS turned on. Next, run the authentication call. Watch the trans status and handle the challenge if the issuer asks for one. Then, pull the CAV, VECI, and DS transaction ID out of post authenticate. And finally, route the authorization to a PSP with that authentication data attached. So, to recap, Standalone 3DS and Hyperswitch separates authentication from authorization. And that separation is what lets one CAVV travel across multiple PSP retry attempts without re-authenticating the customer. The 3DS intelligence engine makes the exemption decision. The 3DS server, Netcetera, Cardinal, 3dsecure.io, or the Juspay 3DS server encodes the indicator. The issuer's ACS decides whether to honor it, and it is allowed to say no. If the customer abandons the challenge, no CAV comes back. So before you route, check post authenticate for a missing authentication value. Forward without it, and the PSP may take the request, but the acquirer declines it one level down. An ECI 05 means the transaction was fully authenticated, and that carries the liability shift. An ECI 06 means authentication was only attempted, and that does not guarantee a shift. The card network rules decide that one on their own. And the switch that turns it all on is request external 3DS authentication set to true in payments create. To import a result from a fully external provider, use the 3DS data object instead. That is standalone 3DS with Hyperswitch. You authenticate once and you can route it anywhere. Thanks for watching. The full docs are at docs.hyperswitch.io, and the architecture write-up is linked in the description. If this was useful, like and subscribe for more.